Okay, class, for those who have just finished the terminologies about probability, the next topic that we are going to talk about in relation to probability is counting the number of occurrences of an outcome in an experiment. And before we get into the topic itself or its application, let us have a quick review of the previous presentation, which is about the terms or terminologies surrounding probability. I want you to complete this picture by putting in the puzzle pieces using the answers to these pieces. A situation or activity involving chance or probability. So, what do you think that is? If you answered experiment, then you are exactly right. Now, let's have the next one, a subset of a sample space. If you said event, then you are correct. How about the set of outcomes of an experiment? That is exactly the sample space. And a possible result of a random experiment is, of course, the outcome. Now, we have completed the puzzle pieces, and now that we can see the complete picture, what do you think the boy is doing? If you said counting, then you have keen observation. The boy is counting, and that is what we are going to talk about today. We are going to count the number of occurrences of an outcome in an experiment. Now, let us use a situation for us to deal with this topic. In Almond Store, there is an available value meal where you can order a combination of a rice meal and a drink. On the chart are the available items for each category. We have four choices of rice meals, namely fried chicken and a rice, two-piece burger steaks and a cup of rice, one-piece burger steak and a cup of rice, and Shanghai roll with rice. And for the drinks, we have pineapple, Coke, coffee, milk tea, Pepsi, and iced tea for our choices. Now, if you will be given the chance to order, what would you have taken? So I bet some of you already took theirs. And the question that I'm about to ask is how many combinations can there really be? So, with that question, we are going to talk about the different methods by which we can count the number of value meals we can come up with using the combination of rice meals and drinks. The first one is the table. The table is a tool used to arrange data in rows and columns. So, your main keyword here are the words rows and columns. When you see those words, table should be implied automatically. How do we use this? We can just put all our rice meal choices on the first row and all our drink choices on the first column. And on the cells where they intersect, for example, um, the chicken rice meal and the pineapple on this cell, and the Shanghai roll with rice and the iced tea on this cell, um, that's where the value meals will be. So now that we have put the value meals, the ones in colored format, we can now count how many combinations there are. And if you counted with me, you should have counted 24 value meals. Now, another way of counting the number of occurrences of an outcome in this event will be by the use of tree diagram. Tree diagram is a special type of graph which uses branches to determine the outcomes of an experiment. And just like with the table, we have a keyword here, and that's the word branches. Because like an actual tree, a tree diagram uses branches in its presentation. For example, if we can have all the rice meal choices displayed first, and it will branch out to all the drinks they can pair with, we can have each of the drinks here representing the pair because they are connected to the rice meals. So if we count all the drinks here at the bottom, we will be counting 24 value meals. And just like with the table, we came up with 24 value meals because we did not change the situation. We just changed the method by which we counted the outcomes. And another one that we can also use is what we call the systematic listing, which is a method on which the outcomes are listed in an organized way to make sure that no possible outcome is missed. And just like the first two, we have a keyword here, which is the word listed itself. So it will imply that it is a type of listing. But let us also not forget this adverb systematic, because that is implying that we are going to do it in an organized way. Why? So that we will not be missing any possible outcome. Because if we did, then we will miscount. So, how do we do that? We can do it in various ways, but for this particular example, we can just put all the chicken rice meals with their drinks first, and then the two-piece burger steak rice meal with their drinks, and the one-piece burger steak rice meal with their drinks, and then finally the Shanghai roll rice meal with their drinks. And we can make sure that we did not miss anything out because we did it in such an organized way. And now we can count how many outcomes there are. And if you counted with me, you would have counted 24 value meals. And since we do not change the situation, it's the same answer as with the former two methods we use. And not to undermine these three methods of counting, but this will take time because it's representing all the possible outcomes. But this is very important or useful if what we have to do is to display all the possible outcomes. But what if we only need to know how many there are? If we actually don't need to list all of them and just need the answer of how many there can be, then we use a different method. Let's look back on where this all started from. Okay, we started from 4 rice meals and 6 drinks. And whatever tool or method we used, we ended up with 24 value meals. So for us to realize what we can do to come up with that answer, let me throw this question at you. What can you do with 4 and 6 to get 24? And I'm sure that you immediately answered multiplication. So if you multiply 4 and 6, you will get 24. And that's the aspect or the principle of the fundamental counting principle, which says if an event can occur in m different ways and another event can occur in n different ways, then the total number of occurrences of the events is m times n, meaning how many we have here times how many we have here will give us the number of outcomes in total. Okay, now let us not have the mistake of whenever we see numbers, we automatically multiply it because that's the usual error that students make. Instead, we have to ask ourselves this question: how many events are there? For this one, we have 2 events: the rice meals and the drinks. And then the next question that we should ask, how many outcomes are there in each event? So that's where we got the 4 for the first event and 6 for the second event. And that's how we got 4 times 6, which is equal to 24. Okay? So you will understand why I'm emphasizing that on the next few questions. Okay, so I want you to give the number of occurrences for the following. I will pause for a few seconds so you can try to answer the question, and feel free to pause the video as well if you need more time, and then just continue it when you are ready to check if your answer is correct. So question number 1, different ways to answer 3 true or false questions. How many ways can you answer three true or false questions? Now, most students will just immediately jump at the conclusion, okay, 3 times 2, because there are 2. 3 times 2 is 6. Okay, that's what I was talking about earlier. That's the false interpretation of the fundamental counting principle. What we have to ask ourselves is, how many events are there? And in this case, the events are the number of questions. So the number of questions is 3. So we should have 3 factors. And then the next thing to ask ourselves, how many choices are there for each question? And since there are only true or false, then we will have 2 for the first question, 2 for the second question, and 2 for the third question. Therefore, the number of ways that we can answer this is 2 times 2 times 2, which is equal to 8. And you might be thinking, what are those eight? Okay, so let me just give you a proof that there are actually eight. So let me show this tree diagram. So you could have answered the first question with true, the second with true, and the third with true. Now, for the next combinations, it can be true, true, false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, or false, false, false. And these last um, leaf will be our representation of how many combinations there are of answers. We have 1, 2, 3, 4, 5, 6, 7, 8. So there really was 8 answers that we can come up with if we are given 3 true or false questions. Now, let's have the second question. How many possible combinations can you have if you have a padlock which requires 3 characters using numbers from 0 to 9 each? Okay, the first question is, how many events are there? So the events are represented by the number of characters, so there are 3. The next question is, how many options are there for each character? So we have 0 to 9. So you have to be very keen on reading, because most students will just jump right in and say 9 times 9 times 9. But that is actually false, because we also have 0. So if we have 1 to 9 plus the 0, then we have 10 choices for each character. So if we have 10 for the first character, 10 for the second character, and 10 for the third character, so we have 10 times 10 times 10, or a total of 1,000 possible combinations of a 3-character password. Now, let me show you that there are really 1,000. So as you can see, I have here an Excel file of all the possible password codes. And if you look at how many there are, it's from 0 to 999. And I already highlighted the cells, so you can see here in the bottom how many there are. So it says count is 1,000. And even if you just count from 1 to 999, there will already be 999 plus the 000, which is one count. So 999 plus 1 is 1,000. Okay, so there really is 1,000 possibilities. Now let's have number 3. Choosing top 5 students in a class of 20 without a tie. So how many ways can we rank 5 students as top students in a class of 20 without a tie? So we have to be very uh, observant of these conditions. So for this one, without a tie, meaning um, the student who received the top 1 rank will no longer be considered for the top 2 rank, and the 2 will no longer be considered for the top 3 rank, and so on and so forth. Now, with that said, for the top 1 students, we have 20 choices because there are 20 students in the class. But since one of them already got the first rank, um, 19 students will only compete for the top two rank, and 18 for the top three rank, 17 for the top four rank, and 16 for the fifth rank. And if we multiply 20 times 19 times 18 times 17 times 16, we will get 1,860,480. So that's how you can use fundamental counting principles. Now, I have here another roulette, and I will be using this so we can integrate with other subjects. There is nothing different that we will be applying here. I just want you to think as if we are taking a quiz on these particular subjects, and I want you to give me the number of ways you can answer the questions on that particular topic, on that particular lesson, using the fundamental counting principle. So let's start. Okay, math. So how many ways can you identify each of the two given as an outcome event, sample space, or an experiment? If you said 16, then you are actually correct. Because again, I said the first question that you have to ask yourself is how many events are there? And if there are two questions, then there are two factors. And how many choices do we have? We have outcome, event, sample space, or an experiment. Four in total. So we have four choices for the first event and four choices for the second event. So 4 times 4 is equal to 16. Let's have another subject. English. Classifying each of four outlines as a sentence outline or a topic outline. If you answered 16, then you are absolutely correct. And why is that? There are four outlines to identify, meaning there are four events. And since there are only two choices, sentence outline or topic outline, then you have two choices for each event or two outcomes. So 2 times 2 times 2 times 2 equals 16. Let's have another subject. MAPE. If you are to identify three conditions as morbidity or mortality, how many ways could you have identified it? If you said 8, then you are right. Because there are three conditions, meaning there are three events. And since the only choices are morbidity and mortality, then there are only two choices for two. So two for the first condition, two for the second condition, and two for the third condition. And multiplying them, 2 times 2 times 2 is equal to 8. Now I will no longer spin the roulette since we only have 80 as the remaining um, unselected. So if we are to classify two ideologies as political or economical, how many ways could we have done it? So if you said 4, then you are absolutely right. And why is that? Because there are two ideologies, meaning there are two events, meaning there are two factors. And for the first factor, there are two choices, political or economical, and so is with the second factor. So 2 times 2 is equal to 4. So I hope you answered everything correctly because we are going to have a seat work after this. So you can be ready for that. Now, what other things can you apply the fundamental counting principles on? Actually, there are many. Counting the number of occurrences of events is widely being used. You can see it in the in counting the number of lock combinations, just like what we did before. Possible passwords, and even daily activities such as knowing how many possible routes you can take to a place and estimating how many food and drink combination you can serve to your family given limited choices. Meaning, not because you only have chicken and few spices, it's always fried chicken. It can be chicken afritada, chicken tinola, chicken adobo, and many other dishes based on your spices. Furthermore, we will see in future lessons that this is a very crucial lesson to learn to calculate the probability of certain events. Let me just re-emphasize that this will be very important once we talk about the probability of simple events. So if we don't know it, then we will not be able to compute for some specific probabilities. So I'm hoping that you will be mastering this prior to you getting to the next video lesson. So I want you to fill in the blanks to check if you can still remember the terminologies that we discussed during the first few slides. The blank is a tool used to arrange data in rows and columns. If you said table, then you got it. Number two, the blank states that if an event can occur in m different ways and another event can occur in n different ways, then the total number of occurrences of the events is m times n. The missing word or words is fundamental counting principle. Number three, a blank is a special type of graph which uses branches to determine the outcomes of an experiment. With the keyword branches, you should have said tree diagram. And number four, the blank is a method on which the outcomes are listed in an organized way to make sure that no possible outcome is missed. Since we are listing, this is the systematic listing. Okay, so I hope you got all those words correctly. Now, for your seat work, I want you to give the number of occurrences for the following. Number one, how many different ways can you answer three questions with four choices each? Number two, how many ways can you come up with a five-character password using vowels? By the way, some of the students still don't know what vowels are. Vowels are A, E, I, O, and U. In our alphabet, that will be A, E, I, O, U. Number three, choosing top three candidates from 20. So those will be the items for the seat work, and I hope you will be getting all three correctly. Now for your assignment, I want you to take note of this and put it in your notebook, and I will be checking this prior to you taking your periodic exam. Again, I will no longer be entertaining late passers of this assignment, and so will be the next assignments. Because again, this is the fourth quarter. We should have learned to be punctual in submitting assignments already. Okay, so that will be all for this video lesson, and I'm hoping to get your seat works, which will now be an assignment since I will no longer have a chance to check them, and your assignment itself to be in your notebook. So thank you very much, and I'll see you in the next video lesson. Bye.